Hello friends, now we are going to learn continuous chapter number 2 solution, in which friends today's topic is liquid solution. As you know friends, solute when dissolved in solvent we get the solution. If only one solute is there and one solvent is there, this type of solutions are known as binary solutions. Binary means two component having solutions and they are called binary solutions. As we learnt in types of solution friends, liquid solvent can make solution with solutes, may be solid friends, may be liquid, so it is liquid plus liquid and gas plus liquid. So there are three possibilities friends. Out of them, this one we learnt in Henry's law friends, and these two here we are going to discuss. Out of them, today's point is liquid solution. When both solute and solvent are in liquid form friends, both can be volatile. What is meaning of volatile? It can be converted into vapor friends, and they can produce what? Pressure. That's why they are, we can say, volatile. The substances which are able to dissolve in the convert into gaseous form and also create a pressure, they are volatile solvents or solutes or volatile components friends. So this is done first by friends the scientist name Raoult friends. So it is known as Raoult's law. As we have seen Henry's law, in Henry's law gas was dissolved in liquid. In Raoult's law friends, we are going to learn liquid solution. Here we will discuss few important things. Two components friends, we will consider components. They are 1 and 2. One component are taken in friends closed vessel. Both components will evaporate eventually, and also friends they will able to make pressure or create pressure, and then after friends we will observe the P total means total pressure by both P1 and P2, that is pressure of component 1 and pressure of component 2, that we will consider one by one. So let's learn what was Raoult's law and what it was given. It was given friends by Raoult in friends 1886, and it was like that. The name of scientist Martin Raoult, he has given that P1 component 1 is directly proportional to x1, which is very much similar to Henry, but he has given that P1 is equal to P10 into x1 friends. So instead of kh, here he put the P10, and P10 is to be considered vapor pressure of the pure component or pure part, pure solute or solvent, so pure component, right friends. So this is number 1, and same to same for component 2, it is P2 proportional to friends x2, and that's why P2 is equal to friends P20 into x2. We are removing the proportionality sign and put the P20 and P10 are the constants. This is formula number 2 or equation number 2. Now friends, as per Dalton's law, which you learnt in class 11, friends, Dalton, named John Dalton, he has given the law of partial pressure. It was law for partial pressure, and it was very simple. P total means the total pressure of all the components is equal to the total pressure of the all component, that is P1 and P2 here. If more, we can consider also 3, 4, whatever present there. So this is P1 plus P2. P total is there, the total pressure of the solution. P1 is the pressure of the component 1. P2 is the pressure of the component 2. So these two values are given in equation number 1 and 2, where I am putting here value of equation 1 and 2 into 3. Then I get, friends, P total is equal to P10 x1 plus, friends, P20 x2. So this is important term we get for Raoult's law, but still it is not completed. Still we are going to convert it, change it into simpler form. Once again I write here, friends, P10 x1 plus P20 x2. Now as you know, friends, for any component x1 plus x2 is always 1. It means the amount of mole fraction of all the components is always 1. That is, we learnt in this chapter initially when mole fraction we learnt. So if we are writing here x1, what is x1, friends? So x1 we want to write, then x1 is equal to 1 minus x2. Here x2 will go to right side. So this is the value I get. If I put this value in the above formula, friends, we get P total is equal to P10 into 1 minus x2, friends, plus this is P20 and x2, same I put. When I open the bracket, P10 into 1 is equal to P10 minus this is x2 into P10 plus P20 into x2, friends. So this is P10 common. If I take the x2 minus x2 as common from this both, in that case I will obtain, friends, P10 minus P20, or I can write it like this, P10 plus x2, then I have to convert this opposite, P20 minus P10. So P total, friends, for the component 1 and 2, I can write that the P10 plus x2 into P20 minus P10. We can conclude this is equation number 5, and this is IMP equation, friends. Always in board exam this type of numericals are asked in which values are given and one you have to find out, friends. So we can conclude one important thing, that, friends, always total pressure or total vapor pressure over the solution, friends, over the solution can be related to the mole fraction, friends, of any one component, friends. Please concentrate. In equation 5, only mole fraction of one component is considered, right? x1 is not here, friends. So this is one term. We can conclude that total pressure over the solution can be related to only one component, and that is one component's mole fraction out of 2. Right, friends? Now let's consider one more thing here, and that is, friends, number 2, which we can say total pressure, friends, over the solution varies linearly. Linearly means, friends, we can say straight line with the mole fraction of component 2. Friends, component 2 we will consider will be the pressure solute. Always as a component 1 we will consider solvent, friends, and component 2 we will consider mostly is solute. And the friends, last third number is depending on the vapor pressure, friends, of component 1 and 2, total vapor pressure over the solution decreases, friends, or increases with increase of mole fraction. What it shows, friend? It shows that if we increase the amount of solute, then, friends, the vapor pressure will change. So this is important term, friends. Three important things you have to remember, friends, and these three important things are very much useful, and you can also draw a graph in which, friends, vapor pressure is taken on, friends, y-axis. This is vapor pressure, friends. On an x-axis, if we make it a box like graph, friends, it is very simple, but concentrate. Mole fraction is taken, friends, here on x-axis like structure. Okay, friends, now this 1 and 2 different conditions we have. Suppose x1 and x2, here is also x1 and x2, both are taken, friends. If, for example, I take value of x1 is 1 here, then automatically x2 will be 0, because total x1 plus x2 is 1. Therefore, if x1 is 1, then x2 will be 0. And here I take value of x2 is 1. In that case, x1 will be automatically 0, friends. So I can write both the things. Mole fraction, if I take x2 here, so vapor pressure I can get here, that is suppose P1 0, and here, friends, it is P2 0. So this is, friends, we can say P total is equal to P1 plus P2 that we just derived, and, friends, also for this x2 is equal to 1, we can consider, friends, this is as P1, and this is, friends, we consider as a P2. Why this is P2? Because, friends, P2 is why? Because x2 is 0, that's why total pressure is P2 only considered, P1 will be, right? And here x1 is 0, that's why pressure of 1 is there, that is 1, and this is, friends, 2. So this is the graph you can consider, and in two different cases we can consider two different formulas, that is P1 is equal to Y1 into P total, as well as P2 is equal to Y2 into P total, friends. So what is it, friends? This is P1, P2, two components we have taken and their pressures are there. P total is the total pressure, and, friends, Y1 and Y2 both are given here, or we can take Y1 and Y2. Y1 and Y2 both are mole fractions of the components 1 and 2 respectively in the vapor phase, friends. This is very important. Vapor phase is important, friends, because we had taken x1 and x2 initially. x1 and x2 are not in vapor pressure, friends. It was in liquid, whereas y1 and y2 are, friends, in vapor pressure phase. So I think you got the point. This is the whole question of Raoult's law we have done today. Thank you, friends.